In this video we will talk about variables, their overriding and dynamic typing. One of the core principles in programming is the don't repeat yourself, or dry principle. What do I mean here? For illustration, let's open imdb.com website, and in the what to watch section, fun favorites, we can see movie cards, and there is a rating of each movie. I am clicking on any card, the first one for example, and on the page of the movie we can see the same rating here, the value of its rating. And now let's imagine for a while that these pages are static web pages, that is, all information is put into them manually. And so we have at least two places where the rating value is used. And it means that if the rating value will change on one page, we will have to change it on another page too. I think it's clear that this is not convenient. So let's create a new Python script. I will use the hello world, the old one, and let's say that we have three identical instructions: print avatar movie and its rating 1, 2, 3. The first one, let's say, is on index page. This one in the movie page, details page, and the last one is in sidebar, for example. I want to do it using the built-in print function. Of course, in a real application, instead of the print function here will be a function that will render these values in an HTML template. And I am oversimplifying this example, but I want to show that there are three places where essentially the same information is displayed. Let's run the code. It's working. We got 3 lines. What's wrong with this code? This code violates the dry principle. Don't repeat yourself. And I repeated myself in 3 places. And this is bad, because if our rating changes up or down, we will have to manually change the rating values in each place where it is displayed. Here we have everything in one file, but what if there are 3 files? Or what if there are 10 files or more? It is a job, it is an extra work that takes the time of a programmer who is paid. Thus, besides the fact that this is an extra work, it is also a waste of time and money. And this is the essence of the dry principle: do not repeat yourself. Okay, we identified the problem. How is this problem solved at the most basic level? And at the most basic level, it is solved by using variables. In this code, in these 3 lines of print statements, we have 3 values that, as we know, can change. And the main idea of the solution is to assign some name to the variable part of this expression. To this, this and this. And then, in the needed places, just use this name. What does it look like? This resembles of abbreviations that we use in text. Another example from real life. Have you ever signed any contracts? Sales contract, for example. Did you notice that your name is used in a contract only once at the beginning, and then there is a phrase like hereinafter referred to as a seller or buyer or something like that? That is it. And further down the text, only the word seller or buyer is found. And this is the essence of variables. In sales contracts, the seller is the name of the variable, and the value of that variable varies from one person to the other. If there is a typo in the name, there is only one place where it should be fixed. So, the changeable part of the code can be named, and then in the needed places we use only this name and the Python interpreter will substitute the name with the value that was assigned to this name. Using of variables has two rules. The first one, any name in Python should follow naming rules. We will talk about them a bit later. And the second one, the variable must be created or declared or initialized before its first use. Let's assume that for our task the rating of the movie can be changed. And now the variable part needs to come up with a name. I think the name rating is fine. Accordingly, the rating is the name that we will use in our code. So I have to choose a place before using it at the first time. Rating is the name of the variable, and now I have to assign a value to it. Then here I put an equal character and then I set its value. For example, 100. The equal character is used for assigning a value to a name. And so the variable is created the first time you assign a value to it. And to get the value of the variable, I have just used it where I want. And let's run the script. Nothing changed. We can see that the value of the rating variable was set in all the places where I used it. Now I will change the value of the variable rating to 120, for example, and run the script again. And we can see that the new value of the rating variable has been substituted again wherever this variable is used. Okay, I said that a variable must be declared before its first use. Otherwise what? I want to move the definition of the variable to the very end of the script, and I want to run it again. And I got an exception, an error message, that the rating variable is not defined. Why so? Well, here at the first line of our code we told to the Python interpreter to use the value of the rating variable in the print statement. At this moment, right here, Python tried to find the rating variable, but it didn't find it. And what should it do? And so Python could not execute our instructions, and so it gave us this message. Well, our code has become a little bit more dry. We got rid of duplication, and one of the problems has been resolved. The value of the rating can be changed in only one place. Here, at the definition of the variable, and the naming rules. Names of variables must begin with a letter or with an underscore. Python is a case-sensitive language, so the variable name rating and this rating with the capital R are different variables. For example, we can see the same exception that the name rating is not defined at line 8 here. This time Python uses this rating with capital R and it returns a message at the second time at line 11. The name of a variable also cannot be a reserved word. There are relatively many of them, but you will get used to them soon. For the names of variables and functions, we use so-called snake case, that is, words in the name of a variable and functions that are separated by an underscore. For example, if, for example, my variable has 2 words, they should be separated by an underscore. As I said, variable is created the first time a value is assigned to it. Subsequent assignments overwrite the previous value. For example, the rating 120 and the next line 3 will be 3. Let's run the code and we can see that the rating variable has the 3 as the value. And this action is sometimes referred to as overriding a variable, and this new value may even be of a different data type. We can say that in Python variables are merely symbols. They don't store any information about the data type or about the restrictions associated with a specific data type. Neither variables store values. Variables in Python are universal in nature. They are always just references to specific objects in the computer's memory at the specific moment of time. I want to emphasize that a variable name is not an object. Let me remind you once again that an object is, roughly speaking, an allocated memory that stores a value, an indication of the data type, a reference count, and possible operations associated with this value. And this can be seen in this example. Let's create the a variable. A that will be equal to 1. And let's get its ID. Here, when Python interpreter reads this instruction, it substitutes the name of the a variable with an integer object that was created in memory and the a variable refers to. Then let's create a b variable and assign to it the a variable as the value. So the b variable gets as the value of the a variable. Let's get its ID. We can see that ID of the a variable and ID of the b variable is the same, because both variables are refer to the same object in the memory. So let's assign to the b variable a different value. Let's say it is a hello world string. Let's get its ID again, and we can see that ID is changed because the b variable refers to the different object. Variables in Python are always references to objects. Most of all, they are like hooks that we hook onto the objects we need. When we override a variable, that is, when we assign a new value to it, then we throw a hook or reference from one object to another object that was created in memory. And this behavior is the essence of the so-called dynamic typing in Python. Python itself determines which type of object needs to be created at a certain moment, and then writes a reference to this object into a variable. It looks like this: a equals to 1, type a, class int, a equals to hello world, type a again. Here, an object of integer type was created in memory and the reference to it was written to the a variable. Then an object of the string type was created and the reference to it was written to the a variable again. That's it for now. In the next video we will again talk about strings in the context of variables, and we will talk about immutable and mutable objects in string formatting. If you like this video, please leave a like and subscribe to the channel. Thanks for watching.